Hi, for today, what we're going to do is take a look at quadrilateral properties. If you are in class on Monday, then basically this is what we are going to go through. If you're not in class, or if I ask you to do some of this on your own and you forget how to do it, then this is a good place to look. My guess is that everybody will not need to watch this video all the way through, but use it more for just quick little reminders. So what we're going to do in the first part of the quadrilaterals chapter is take a look at different quadrilaterals, like the parallelogram, rectangle, rhombus, trapezoid, that kind of thing, and just kind of quickly review the properties that each of the quadrilaterals have. And what we're going to do is actually test those properties. So I'm not just going to tell you the properties, but you're going to come up with them and decide whether or not the properties hold true for each of the parallelograms. So on your calculator, if you turn to the second page of your document, you have a picture of a parallelogram. Now, if you do not have your calculator, you can take any parallelogram that you can find, so a picture of any parallelogram, or even draw a parallelogram, and you can still go through and do the same tests by hand. So, what I have in your packet, and you can see it over here on the side, I've given you a list of properties, and what we're going to take a look at on the first day is just the parallelogram. Now, on your calculator you have a picture of a parallelogram. What we're going to do is read through the properties and try to figure out what we could do to test to see if the property holds for that parallelogram. So basically we're going to try to figure out if the property is true, yes or no, and then give a reason why. So first property on our list is both pairs of opposite sides are parallel. Now, with a parallelogram, it seems kind of obvious that both pairs of opposite sides would be parallel if it's a parallelogram, but we need to come up with a test. So one thing, just to kind of refresh your memory, if lines are parallel, it means that they have the same slope. So if I click on the bottom half of my screen and go to Menu, what we're going to do for most of these is measure something. So if we look at our options, we can measure length, area, slope, and angle. Now, we said that parallel lines have to have the same slope. So the test that I'm going to do is I'm going to measure the slope of each side. So I'm going to point to my parallelogram and measure the slope of that top line and the slope of the bottom line, and those are the same. So because they have the same slope, they are parallel. And then I'm going to do the same thing for the left side and the right side. Measure the slope, and we see that they are the same. So we can say that both pairs of opposite sides are parallel. So on our chart, yes, and then y, we can say that they have the same slope. Okay, so that's the test that we did to show that they are parallel. Okay, the second one, are both pairs of opposite sides congruent? Well, for this one, what we want to do is measure their length. So again, I'm going to go to Menu, I'm going to go back down to Measurement, and I'm going to measure the length of each side. So there's the first side, and the side across from it, and then I'll do the left side and the right side, and we can see that both pairs of opposite sides are the same length. So yes, opposite sides are congruent, and y, again, same length. Now, are exactly one pair of opposite sides parallel? Well, we already kind of answered this one. We found the slope of all four sides, and we saw that both pairs of opposite sides are parallel, so we can't have exactly one pair if we have both. So this one would be a no. And the reason why is that we have two pairs of opposite sides that are parallel. Now, the next one, exactly one pair of opposite sides are congruent. Well, again, we already have this information. In our picture, we measured the length of all four sides, and we found that both pairs of opposite sides are congruent. So no, there is not only one pair of opposite sides congruent, and again, we have two pairs that are congruent. Next one, again, we have all the information already on our picture. Are all of the sides congruent? No. We have two pairs that are congruent. Not all of them are congruent. Alright, the next one we actually switch to the diagonals. The diagonals are the segments that go from corner to opposite corner. And so in this picture we have two of them, from corner to opposite corner, and they go all the way through the shape. So what we want to do for this next property is figure out if the diagonals are congruent. So if we want to figure out if they're congruent, we're going to measure their length. Since I already have my length tool open, I'll just go ahead and measure. The first one is 7.18 centimeters, so I'm going to stick that down here. And the other one is 5.8 centimeters. So they are not the same length. So we'll say no, and again, they are not the same length. Okay, for the back of the page, what we're going to do again is just flip our paper over and test the rest of our properties. Okay, for the beginning of this second side, the first thing that we want to see is if the diagonals are perpendicular. So let's go back to slope again. We said that if lines are parallel, they have the same slope. Well, if they're perpendicular, remember that they have opposite reciprocal slopes. Okay, so that's one thing that we can do. The other thing that we could do is we could measure the angles and see if the angles are 90 degrees. So again, those are two options. It's up to you, whatever you like best. For me, I think I'm going to measure the angles. And if I measure the angles where the diagonals meet, if one of them is 90, then all four of them will be 90. If one of them is not 90, then all of them are not 90. And so what I did here is when I measured the angle on top, it turned out to be 126 degrees. So no, the diagonals are not perpendicular because I did not get 90 degrees. Alright, do the diagonals bisect each other? Now, with this one, it's kind of a tricky thing. If the diagonals bisect each other, then what that would mean is that they cut each other into equal pieces. So this piece here would be the same length as this piece here, and same thing on the other diagonal. Another way to test and check is if the two segments have the same midpoint. And for some people that's kind of a hard thing to think about. If they have the same midpoint, then they bisect each other. Again, you can go through and you can measure all four pieces, but if you're trying to save a little bit of time, what you might want to do is just see if they have the same midpoint. Now, midpoint is not in our measurement menu, it's in our construction menu. So I'm going to go to midpoint, I'm going to point to the first diagonal and see how it kind of pops up there. And then I'm going to go to the second diagonal, point to it, click, and again it pops up in the same spot. So because they have the same midpoint, those diagonals bisect each other. So back to our chart, do the diagonals bisect each other? Yes. And why? Because they have the same midpoint. Now, if you did another test, that's fine. Your reason might be different. If you measured the length of all the pieces, then you would say yes, because the diagonals are broken into equal pieces or something like that. All right? Okay, next one. Both pairs of opposite angles are equal. For this one, what I'm going to do is actually measure the angles. So I'm going to go into Menu and Measure Angle. Now, at this point, you may have a ton of measurements on your paper. If you want to move them off to the side so that things aren't messy, you can do that. So I'm going to measure the angle in the upper left-hand corner, and that turns out to be 75 degrees. Then I'm going to measure the angle opposite that, so in the lower right. Remember, to measure an angle, you have to click on 3 points. And that one also turns out to be 75 degrees. So looks good so far. Then I'm going to measure the other two. So lower left is 105, and upper right is also 105. So are the opposite angles congruent? Yes. And why? Because they are the same measure. Next one, is there exactly one pair of opposite angles congruent? Well, if there's two, like we just saw, then for this one we have to say no, and again, because there are two pairs that are congruent. And then the next one, again, pretty simple. Are all of the angles congruent? No, we have some angles that are 105 in our picture and some that are 75, so those are not congruent. Again, our reason, we have two pairs that are congruent, not all of them. The next one, are consecutive angles, do consecutive angles have a sum of 180 degrees? Now, consecutive angles means that they're angles that are next to each other. So if you pick any two angles that are next to each other, not across from each other, but next to each other, do they add up to 180? So if I look at this angle up here in the upper left, and I look at one next to it, like the upper right, one is 75 and one is 105, and they add up to 180. If I look at another pair, like the two pairs that are on the right-hand side, they add up to 180. The two angles on the bottom that are next to each other add up to 180, and the two angles that are on the left-hand side that are next to each other add up to 180. So, are consecutive angles, do they have a sum of 180 degrees? Yes. Why? They add to 180. Okay. Now, the next one, opposite angles are congruent. That, I think, I actually meant to be, and I know that this is weird, but do the diagonals bisect the angles? Okay, so that's me. Do the diagonals bisect the angles? Well, if we take a look at an angle, we know that this angle up here is 75 degrees. Does the diagonal cut that angle in half? Well, for some of you, you can already see the answer. But if not, what I'll do is measure. I'm going to measure those angles. So I have an angle that goes from here to that vertex down to the opposite side, or opposite angle. That one's 51.3 degrees. And then I have the upper half of that angle, which is 23.7 degrees. Now, if you notice, the two angles add up to 75, but they're not equal to each other. So because they're not equal to each other, the diagonals do not bisect the angles. And why? Because the angles are not congruent. Okay, so that's it. Basically what you're doing is just going through and testing the properties. What I don't want you to do is just circle random yeses or nos, because I'm not going through every single one of these. You have to actually truly test all of your properties for each of the shapes. If you continue through the document, you have a picture of a rectangle, you have a rhombus, you have a square, you have a trapezoid, an isosceles trapezoid, and a kite. So at this point, if you want, you can go back through and test all the properties for all of your shapes. The rest of your packet is just taking those properties and applying them to algebraic problems. Okay? So that is your lesson for this week.